Welcome back. Today we're going to be looking at. But before we go ahead and begin, let's talk about a problem that we've already done in from Chapter 8, Part 1. Alright, diver is standing on a 6-foot platform high dive. The path of her dive is represented by this equation, and this is the graph of this equation right here, where T represents the time passed once the diver jumps, again in seconds, and H represents the height in feet of her dive. The diver starts right here, jumps off, and then goes down and then hits the pool. So, what is the diver's max height? Well, the diver's max height would be this point right here, which is the vertex. Remember, height, the time, is the x-axis, and y is the height. Max height would be 2 feet. And what time does the diver reach her max height? Well, that's just the x-coordinate. So the diver reaches her max height at 4 seconds. Using the given graph, estimate how long it would take the diver to reach the pool. Remember, this diver reaches the pool right here. Anything under, she's in the water. So I would say it's around like maybe 9.3 seconds. Again, we've always estimated this. Now today what we're going to learn how to do is be able to find the exact time the diver hits the ground or the pool, because normally an estimation is not always very accurate. Someone might say 9.5, I might say 9.3, someone even might say 9.2. We need to know the exact height. Okay, so what is the height of the diver once she reaches the pool? What is the height of anything when they're on the ground? If they reach the pool, they're on the ground, the height is going to be always 0. So now we're going to use this equation that I highlighted above, and we're going to substitute 0 in place of h because the height is 0. So 0 is equal to negative 0.5 t squared plus 4t plus 6. Now, let's go ahead and use the quadratic formula to solve for t. We have a quadratic equation. I don't know about you, but I don't really want to factor a 0.5 t squared, so I'm just going to jump straight into the quadratic formula. Remember, that's the last video. So the first value is negative 0.5, b is going to be positive 4, and c is 6. So we can always use the quadratic formula to solve any quadratic equation. But before you use it, you just have to make sure it's equal to 0. Instead of x equals, we're dealing with t, so I have t equals, it's the opposite of b, negative 4, plus or minus the square root of, now this formula again will be given. Okay. It's b squared, so 4 squared in parentheses is 4, times a, which is negative 0.5, times c, which is 6. All divided by 2 times a, which is negative 0.5. Again, we're going to put everything under the square root, not including the square root in our calculator. When you put parentheses 4 parentheses squared minus 4 parentheses negative 0.5 parentheses 6 in your calculator, you're going to get negative 4 minus the square root of, and you get number 28 divided by negative 1. All right, let's go ahead and separate my two equations. We'll go ahead and open my calculator so you can see how I'm calculating this. Remember, you have plus or minus, means you have to do 1 with the plus and 1 with the minus. All right, so we're going to split parentheses, negative 4 plus square root of 28, throw out parentheses, divided by negative 1, because 2 times negative 0.5 is negative 1. So one of my solutions is negative 1.29. Negative 1.29. All right. Now remember, if you have to shortcut the 84, the colored one, the plus, you can press alpha, y equals theta, and then you don't need to have the parentheses. But if you do not have that shortcut, you will have to put the parentheses. So here, We have negative 4 now minus square root of 28. Barrel down, negative 1. Oops, negative 1. Press enter, which is 9.29. So now, which value do we choose? She doesn't hit the pool more than once. We're going to choose 9.29 seconds. Because why? Time can never be negative. So we actually don't use the second option. So we are pretty close. We said it was probably about 9.3. Exactly, it was 9.29. All right, let's continue. Jake is practicing kicking field goals on the football field. The path of the football is represented by this equation. H equals negative 3 squared plus 21t. Where again, t is the time the football is in the air in seconds, and h is the height of the football from the ground in feet. So now we're going to be working with these problems that we will not have the graph. But we don't need the graph once we have the equation because we already know how to solve. So part A, how far above the ground will the football be at the I give you 2 seconds. Is 2 seconds T or H? Hopefully you said T. So now, in this equation, I'm just going to substitute 2 in place of T to find the height. So negative 3 times 2 squared 21 times T, which is 2. About whole thing in your calculator, you're going to get 30. To get even make sure whatever you're using. Okay? Now, what I need you to make sure you're careful with is part A and part B are 2 totally different parts. So just because I put 2 in place of T for part A doesn't mean 2 goes in place of T for part B. I start scratch from the original equation. Now, part B says how long will it take the football to hit the ground? So now we're talking about hitting the ground. What do I know about any object without the ground? Hopefully you're saying the height is always going to be 0. Again, anytime the object is on the ground, the height is always 0. So I'm going to start from the original equation. Instead of 8, I'm going to put 0 equals to negative 3t squared plus 21. Solve for t. Well, we have a quadratic equation, so remember we're either going to do the quadratic formula, factor, or inverses. Remember that's square roots. We'll just have that linear term. Let's go ahead and factor. Okay? So I always check for DCF, and I do have a DCF. I'm going to follow the leader, so the leader is negative. I'm going to plot negative equals 0t. The DCF is negative 3t. 0 equals negative 3t. I'm going to put t minus 7. Remember, I have negative 3t times t minus 7. But the zero product property means that both of them equal to 0. I'm going to set negative 3 equals to 0 because the positive 3 box. If it was just negative 3, I would ignore it. Okay? And I'm also going to set 2 minus 7. From here, I'm going to divide by negative 3, so it's going to equal 0, and add 7 equals 7. So what time do you think we're going to take? Did I kick the ball when time is 0? No, I didn't kick the ball yet, so I'm going to choose 7 seconds. Answer when the football hits the ground. If you think about it, when you kick a field goal, it starts on the ground, so that's when t equals 0. I kick it, it goes all the way up, and it comes back down, so that would be at 7 seconds. All right, on to the next page. Number 3. Justin's new cat Franklin ran away from home and got stuck in a tree. The fireman used his ladder to go all the way to the top of the tree to save Franklin. Unfortunately, as soon as the fireman picked up Franklin, he dropped the cat and he fell to the ground. Luckily, cats always land on their feet. The vertical motion of the cat is represented by this equation. Go ahead and circle that. Okay. Where t is the time Franklin is in the air in seconds, and h is the height from the ground in feet. So again, part A. How far above the ground is Franklin after 0.5 seconds? I give you 0.5 seconds. Is that the time or is that the height? Since it's seconds, it's the. So in this equation, everywhere I see 2, which is just 1, I'm going to substitute it 0.5. H will be to the 16 times 0.5 squared plus 40. Then all of your calculator and you can get 36 feet. So a half a second after Franklin dropped, he is 36 feet above the ground. Now again, just because I put 0.5 in for T for part A does not mean 0.5 is going in T for, well, they are two totally separate parts. I'm going to start with the original equation. All right, part B. How long does it take Franklin to land on the ground? So what do we know about the ground? What is the height of the object, of any object when it's on the ground? The height is zero. Again, we're going to start from the original equation. And then 0 and 8 will it was 0. And 0 equals negative 16 squared plus 40. These are two totally different parts. We start from the original equation. The cap pops up as having 0.5 in place of 2. All right, well, I have a quadratic equation. We've been practicing all the last couple of videos solving. So again, we have to choose from factoring, inverses, square root method, or the quadratic formula. If you know this, you have a constant, a quadratic term that's negative 16 squared, and then a constant. You do not have a linear term, so we're going to follow that method. First thing that you're going to do, you got to get rid of everything and it is first. So negative 16 times 2 plus 40, so we get rid of the 40 first. Negative 40. Now I got to get rid of everything that's not divided. So we would have negative 5. Negative 40 divided by negative 16, I'm going to jump up, is positive 2.5. Now I'm going to get rid of everything. Let's do the exponent. So how do I get rid of the square? Well, I square root. So with the square root and the square, cancel, drops down, we go off with plus and minus, and then the square root of 2.5 is rounded to 2.58. Okay? But you have two solutions. Which solution do we choose? Do we choose the positive 1.58 seconds or the negative? Hopefully, we say the positive 1.58 seconds. And why do we only choose the positive? So the next part, why is only one of the answers appropriate? I because time cannot be negative. Part B. What does the y-intercept represent in this specific problem? Remember, the y-intercept is always going to be c. So we'll see y equals x squared dx. What is c here? C represents 40. So 40 feet, what does that represent in the question? Remember, the y-intercept is always the starting point. So the way to think about it is, where did Franklin, the cat, start at? Franklin started at the top of the tree. So 40 feet represents height of the tree. All right, last question. Sergio did not bring a pencil to math class, so we needed to borrow one of Mrs. Wojcik's. Again, apparently Sergio doesn't bring a pencil. While taking notes, he accidentally fell asleep and his pencil fell to the ground. The path of the pencil is represented by this equation. Again, let's circle it. I'll highlight it. Where t is the time where the pencil is in the air in seconds, and h is the height above the desk in feet. All right, so part A. How far above the ground will the pencil be at 0.25 seconds? Yeah, give you 0.25. Is that t or h? Since t is time, 0.25 becomes t in this equation. So h equals negative All right, part B. How long did it take for pencil to hit the ground? Well, again, what do we know about any object that's on the ground? What's the height of the object? The height is always zero. So zero is the place of h. Again, I'm going to start from the original equation. Part A and part B have nothing to do. Negative 6 plus 4. Then we have a quadratic equation. How do I solve? Well, we're either going to factor inverses, which is SATMAP, or quadratic formula. But if you notice, you don't have a linear term. I see a constant, a number, quadratic, another constant. So let's go ahead and do that. X, A, M, E. Let's go ahead and cancel everything that's being added to the bracket. I have negative 16 times c squared plus 3. So I do, it's 3. Start with adding the subtract, so negative 3 is equal to negative 6 squared. We're going to move on to everything that's multiplied and divided. I talked about negative 16. Now, when I do negative 3 divided by negative 16 in your calculator, you're going to get 0.1875. Do not round that answer. You are not allowed to round the answer till your very last step. So whatever that says on the calculator, you're going to write all 4 digits. So here, I'm going to move up. That is 0.1875. Do not round until the very last. Okay, the next one here. By square root. Remember the square root, the square cancels the two drops down. Remember, when you do the square root, you get plus or minus, and then round it to 0.43. Well, what answer do we take? We're only going to take the positive. So the pencil's going to hit the ground at 0.43 seconds. All right, and part C. Why is only one of the solutions for time appropriate? Remember, I have 2 solutions. Why did we only choose one? Because finally, time not be negative. I can say time is always positive as well, which is the exact same thing. All right, go ahead and stop the video and complete the homework.